All right, we're going over the homework today with the distributive property, and we've got a special guest with us. Mr. Walutis is here. Say hi, Mr. Walutis.
How is everybody out there?
They can't respond to you because this is pre-recorded, so it's just a rhetorical question that doesn't have an answer.
I hope you're all well.
Okay, very good. All right, the distributive property, reminding yourselves that is just taking a term and distributing it. There's no other way to put it. All right, so let's look at the first one here. We have 6 times the quantity of h minus 4. I'm going to take that 6 and I'm going to distribute it to everything in the parentheses, because to the quantity means to everything in there. So h, reminder, there's an imaginary 1 in front. So Mr. Walutis, 6 groups of 1 horse. How many horses do you have?
6 groups of 1 horse?
Yeah.
6.
Yeah, just 6h, right? So 6 times h is just 6h. And then you've got 6 times 4, which is
24.
24, and then you got the opposite symbol in there, so that's just 6h minus 24. Now, Mr. Walutis, can you combine horses with non-horses? And no, it just doesn't work, right? So 6h and negative 24, we can't combine those. You wind up getting this weird variable expression, but that is your answer, right? That's why the directions always say simplify, because sometimes you can only go so far. All right, Mr. Walutis, we've got p plus 3 times 5, right? But I got the 5 coming in the back. So if knock, 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 coming in the back, nobody's there at the back, what do most people do? They go to the front, to the front door, right? Yes. So boom, I'm going to cross off the 5. I'm going to bring it to the front. Not that you have to do that, but I like it. It makes the problem a little bit more, I think that we see it that way more often, all right? So 5 times p, Mr. Walutis, 5 times p. 5p, I like it. 5 times 3?
15.
15, and everything's positive, so that's just 5p plus 15. Next set of problems. Are you prepared?
I'm going to try.
All right. I like that attitude.
What about you guys?
I hope so. All right. We're going to take this negative 3, and we're going to distribute it. So I'm not going to look at the signs. Let's just distribute 3. What's 3 times x, Mr. Walutis?
3x.
3x. What's 3 times 8?
24.
24. And then we've got the opposite symbol, right? So now ignore the 3. We already did it. The opposite means the opposite of this term and the opposite of this term. So you wind up getting negative 3x minus 24. 6. Let's just do, hey, it's coming in the back. Let's do it that way. All right. Mr. Walutis is going to help us out. Ignore the negative. 9 times 4 is?
9 times 4 is 36.
36. He likes to say the problem again to give him some more time.
It makes me feel good.
That's fine. All right. 9 times y?
9y.
9y. And now notice, I've got the opposite of positive 4, which is negative. Now this is the tricky part. The opposite of negative y is?
Positive?
Positive y. And realize that could also be written backwards. Positive 9y minus 36. Every answer you can write 2 different ways in this situation. All right, let's distribute the 2. 2 times 7n is 14n. 2 times 11, this is my solo because you're not helping.
Okay.
22. And notice I only have 1 negative in the problem, so I only have 1 negative right there. 14n minus 22. You're going to help us with this hard problem, Mr. Walutis. I'm distributing negative 10 to 2 terms. All right? But I'm going to make this easier for you. What's 10 times a?
10a.
10a. What's 10 times 5?
50.
50. Now I'm going to go back and do the signs. See how easy this is? He's not even looking at the problem and he's doing it. What is the opposite of negative?
Positive.
So this is a positive 10a. I don't have to write that, right? And what's a negative times a positive?
Negative times a positive is a negative.
Negative. So your answer is just 10a minus 50. And again, you did that not even looking at the problem, so you're pretty good. All right. Next one. 98 times 7. Can you do 98 times 7 in your head? Yeah, he's struggling, guys. I'm letting you know. He's really struggling over here.
I would say it's 684, 86.
All right. Well, we're going to make that harder problem into 2 easier problems. We can all multiply by 7. So let's change that 98 into something that's easier to deal with. Let's make it 100 and then subtract 2. We can all do 7 times 100. What is it? 700, right?
Yes.
You got to listen. All right. 7 times 2 is 14. And then you could subtract those 2, right? 700 minus 14 is, I like to subtract 10. Yeah, I like to subtract 10 and then subtract 4 more. Oh, okay. And you get 686. Is that what you said?
Yes.
I don't know.
I said either 686 or 684.
We could rewind that and check that. All right. But let's move on.
People. Now we're going to see if I was right.
98 times 7. Can you do 98 times 7 in your head? Yeah, he's struggling, guys. I'm letting you know.
hard.
He's really struggling over here.
I would say it's 684.86.
All right.
I was right!
Another way to do that problem is doing 7 times 90 plus 8. All right. In that case, you get 630 plus 56. It's a little bit weirder to do it that way, but you can, definitely. All right, 9 times 28, Mr. Lewis. Can you count by 28s?
No.
No. What's close to 28?
30.
You could say 30, right? You could say 30 minus 2. That'll get you back to 28. 9 times 30 is?
240.
270. All right, try again.
Oh, I'm sorry.
Yes, and then 9 times 2 is 18.
Right.
Right? There's a reason why you're a librarian. But hey, we're working at it. That's a put down. I'm sorry. I'm sorry.
I'm still going to keep working hard.
I like it. All right. 270 minus 18 is 252. You could also do this problem as doing 9 times 20 plus 8. Some people prefer to do that. And you get 180 plus 72, which is going to give you the same exact answer. All right, Mr. Ludis, can you do 8 times 78?
It's a little bit difficult. I'd have to go 8 times 80.
Yeah, let's do 8 times 80. Nice round number. And then let's subtract 2, right? So, Mr. Ludis, 8 times 80, what do you get?
Is it 64 or 640?
64, and then you add the 0, right? 640. 8 times 2 is?
16.
And then you subtract the 2, and you wind up getting 600.
And
let me help you.
640?
Subtract 10. What's 640 minus 10?
630.
630. Now subtract 6 more.
624.
Yes, that's the easiest way to do it, right? Subtract 10, then subtract 6 more.
No,
We're trying to lead you into do these problems mentally. All right, so let's try to do this problem mentally. 7 times 2009. 7 times 2,000 plus 9. So what's 7 times 2,000?
14,000.
You got 14,000, right? And what's 7 times 9?
7 times 9 is 63.
Yep, so you wind up getting 1463. Very good.
I'm starting to come along.
You are. You're doing all right. I'm going to do this problem a little bit differently. Mr. Lewis, 5 times 899. Let's actually do it 2 different ways. 899. What's close to 899?
900.
900. And then we subtract 1, right? So, Mr. Lewis, 5 times 9 is?
45.
45. Add those 2 zeros.
Which
5.
is 4,500, right?
Yep. And 5 times 1 is?
5.
And then subtract the 2, right?
4,400.
4495. Very good. That's good mental math. Now, if you wanted to, check this out. Not that you'd want to do it this way, but could you do 5 times 800 plus 90 plus 9? Could you spread it apart that much?
I would say you can do that, but...
You could, and distribute 3 times. That would be, 4,000 plus 450 plus 45. That gets a little confusing. But just to let you know, you could break it apart as many ways as you want to. Okay?
Right.
All right, Mr. Ludis, 30 times 105. I'm going to lead through this one to make it a little bit quicker.
Okay.
We're going to do 30 times 100 plus 5. 30 times 100 is 3,000. Plus 30 times 5 is 150. So you wind up getting 3,150. Sounds good?
Yes.
All right, 8 times 5 minus 12 times 5. They're both times?
5.
Both times? Yeah, both times 5, yeah. We're doing a little like a little cheer. When I say 8, you say 5. No. All right, they're both times 5. So what we're going to do is, since they're both times 5, I'm going to pull out the 5. And what's left over? The 8 minus 12. Well, that 8 minus 12 is going to gang up on that 5. 8 minus 12 is -4, and 5 times -4 is -20. So let's do that kind of problem one more time. Mr. Ludis,
Yeah.
7 times 10 plus 7 times -3.
7 times
They're both
10 is
times,
seven.
well,
Oh,
wait.
Okay.
They're
All
both
right.
times what?
7.
Yeah, so you could definitely do 70 minus 21. Or you could just say, all right, they're both times 7. So I'm going to pull out the 7, right? They both have the 7 in common. So let's pull it out. It's doing the opposite. It's doing like the distributive property backwards. So, Mr. Ludis, you can't see this, but what's 10 minus 3?
10 minus 3?
Yep.
7.
Is 7. And now you just have to do 7 times 7, which is?
49.
49. Pretty cool, right? Pay attention, because I'm going to put a challenge problem in the bottom. And if you do this same strategy, you're going to be able to solve the challenge problem. All right, Mr. Lewis, -4 times 3 plus -4 times 6. They're both times?
4. 3?
No.
6.
Listen clear.
I'm getting nervous. Okay.
-4 times 3 plus negative 4 times 6. They're both times
4.
negative 4. Negative
Oh,
4. They're both
okay,
times
I'm
negative.
sorry.
It's,
All right,
it's
I'm
all right.
trying.
Gosh.
Okay.
All right. So they're both times negative 4. Pull out the negative 4, Mr. Walutis. And you have 3 plus 6. Don't put your head down.
I'm getting worn out here.
Negative 4 times. Now these two are going to gang up. And it's negative 4 times 9, which is negative 36. All right. And the final problem. Let's help you out. 6 times 8 plus 6 times negative 2. They're both times
6.
Yes, thank you. He's a little hesitant now. He doesn't want to
Yeah.
make a mistake. What's left over? 8 minus 2. Let's do 8 minus 2, and you get 6 times 6, which is 36. All right, you might say, why would I just do that, Mr. Babiak? Why can't I just do like 48 minus 12? That's easy. All right, well, let's say you have this crazy long problem. 3 times 6,054 minus 3 times 6,052. Now you might say, oh my gosh, that would take me forever. Well, Mr. Walutis, 3 times 6,054 minus 3 times 6,052. They're both times
3.
3. So watch. Check this out. 3. Now, can you do this mentally? Can you do this minus this? What would you get? Well, you don't see it. It would
Yes, I'll say yes. I can.
If you could do that mentally, listen, it's basically looking at this problem and saying
Right.
3 times 2. 3 times 2 is
6.
6. Since they're both times the same thing, you can do that.
Okay.
All right? So we're leading you up to try to do these problems mentally. Hopefully you did well. You're going to get better the more you do. I keep saying that, but don't give up and keep trying your best, and we'll get there together.
I've been doing it for 10 years, so keep
And
working.
he's getting a little better every year. Okay? Very good, guys.
I
Keep
need
on working.
water.
See ya.